Welcome to this explainer. Today we're unpacking something literally hidden in plain sight. It's a fascinating cognitive skill that quietly powers basically everything you do, from backing your car into a tight spot, all the way to your ultimate professional success. We're decoding spatial ability. We're going to be drawing on some really compelling academic research and curriculum studies to give you a comprehensive summary of exactly what spatial ability is, how it works inside our brains, and why it is absolutely critical for today's classrooms. Let's get into it. Here's a quick look at our roadmap. We're starting with what is spatial ability. Then we'll check out cognitive functions, everyday spatial thinking, compare a couple of curriculums, dive into teacher competence, and wrap up with our geospatial future.
Section 1. What is spatial ability? Let's define the concept.
I really want you to stop and think about this for a second. How does our mind actually perceive and structure space? It's super easy to assume that spatial ability is just, being able to read a map on your phone or knowing your left from your right. Because we do these things on autopilot, we kind of take them for granted. But as the research clearly shows, it's a much deeper, far more intricate psychological process than we usually give it credit for. It is literally the invisible framework we use to make sense of the physical world around us. So there's this landmark 2006 report by the National Research Council that our sources reference heavily. They define spatial thinking as a cognitive blend of three specific elements. First, you've got the concept of space itself, understanding fundamental ideas like location, dimensions, proximity. Second, the tools of representation. These are the instruments we use to communicate space. Think graphs, maps, or even just those mental images you picture in your head. And third, the actual process of reasoning. This is how we take those abstract concepts and visual tools and combine them to solve problems or make real-time decisions.
Section 2. Cognitive functions, the dimensions of thinking.
The National Research Council breaks down three core functions of spatial thinking, and I think this brilliantly illustrates just how deep this skill goes. Number 1 is the descriptive function. This is just identifying appearances and immediate relationships, recognizing a landmark or noting the distance between two buildings. Number 2 is analytical. This is where we understand underlying structures, like looking at a map and figuring out exactly why a city's roads are laid out in a grid pattern. And number 3 is inferential. This is where we start predicting changes. If you're outside and you see dark clouds rolling quickly over mountain range towards you, you infer a storm is coming, right? It's this highly dynamic process constantly running in the background, letting us interpret the past, navigate the present, and anticipate the future. Moving on to Section 3, everyday spatial skills in our daily routines. Okay, let's bring this down to earth. You might not even realize it, but you are a spatial thinker every single day. Planning a route to a new coffee shop and visualizing the turns in your head before you even make them, that's spatial reasoning. Using GPS on your phone and translating that flat, top-down digital view to the actual 3D street in front of you, you are effortlessly blending technology with your innate spatial awareness. Even something totally domestic like arranging furniture, trying to figure out if that massive sofa will actually fit up the staircase without getting hopelessly stuck. We've all been there, right? That requires an intense understanding of spatial relationships, angles, and dimensions. It bridges the gap between what we want to do and the physical environment we have to do it in. Section 4. Curriculums Compared. Looking at educational frameworks. Now, when we look at how this is taught, things get really interesting. Our source material highlights the Canadian National Geography curriculum, and the sheer volume of spatial concepts they integrate is just impressive. Notice the top rows here. Foundational terms like location and map are repeated a staggering 119 times across the 9th to 12th grade curriculums. That's huge, but it goes way beyond the basics. Concepts like region, spatial distribution, and scale are also heavily prioritized. This frequency isn't just a happy accident. It shows a very deliberate, systemic commitment by educational planners to build spatial literacy year over year. Conversely, the data mapping the Turkish geography curriculum shows a remarkably different structural approach. While foundational concepts like map and region still pop up enough to provide a baseline, a lot of the vital, more advanced spatial concepts are completely absent. Terms like spatial data, spatial distribution, navigation, and symbology are actually clocking in at 0 repetitions across the board. So this points to an educational framework that introduces the idea of space, but perhaps misses the opportunity to really train students on how to analyze and interact with complex spatial information. To impartially summarize this structural difference, the Canadian curriculum actively uses a really high frequency of spatial concepts, 58 distinct terms categorized into 17 core ideas to drive cognitive development.
The Turkish curriculum, according to the researchers, demonstrates a much lower frequency, entirely missing operational concepts like navigation and spatial data. The researchers argue that a modern curriculum absolutely must integrate these missing elements, because without them, it's incredibly difficult to prepare students for a complex, 3D world where spatial problem-solving is practically mandatory in almost every modern industry.
Section 5. Teacher Competence and Professional Success.
Now you might be wondering, does this actually matter for professional success? Absolutely. It isn't just a theoretical concern for students, it directly impacts educators. A fascinating 2025 study by researcher Alaaddin Arakan looked closely at 262 pre-service teachers. The research model was meticulously designed to explore how a teacher's spatial skills, their 21st century skills, and their traditional academic achievement all interact. But the real goal? Measuring how these factors predict their overall professional competence in an actual real-world classroom setting. Basically, what makes a teacher practically effective when they're standing in front of a room full of energetic students?
The crucial point is captured right here in the study's findings. Arakan notes that while 21st century skills were the strongest predictor of professional competence, spatial skills were the second strongest predictor. Actually, scratch that. The most amazing part is that spatial skills came in ahead of standard academic achievement. Let that sink in for a moment. The ability to think spatially is a stronger indicator of a teacher's professional, real-world success than their raw academic grades. High spatial ability allows teachers to navigate complex problem-solving, organize information visually, and just manage the physical dynamics of a bustling classroom. Teaching isn't just knowing the facts, it is fundamentally about organizing space and relationships.
Final section. Geospatial future. Tomorrow's technologies.
Let's face it, technology is pushing spatial thinking to the absolute forefront of modern society. We're living in an era dominated by geographic information systems, or GIS, mapping out incredibly complex layers of environmental and urban data. We rely heavily on GPS, remote sensing from satellites tracking climate change, and an endless sea of mobile apps guiding our daily commutes. These technologies don't just require humans to have a basic level of spatial awareness anymore. They actively demand and stretch our spatial reasoning to operate them effectively. As these tools become more embedded in our infrastructure, spatial ability transitions from a nice-to-have life skill to an absolute professional necessity.
Bringing all these sources together, the prevailing conclusion is incredibly clear. Whether it's to navigate the physical challenges of daily life, utilize advanced geospatial tech, or ensure high professional competence, especially in demanding fields like teaching, our educational programs have got to evolve. Curriculums need to comprehensively and intentionally include spatial skills at every single level of development if we want to truly prepare people for the demands of the 21st century. It's high time we treat spatial ability with the exact same weight we give to reading and math.
I want to leave you with a final thought to ponder today. Knowing that spatial ability is a crucial predictor of professional success and really the master key to navigating our heavily mapped-out world, how do you shape your own spatial perception in the digital age? Are you actively developing it, or are you just letting the GPS do all the thinking for you? Thanks so much for exploring this with me today on this explainer. Keep learning and for sure, keep thinking spatially.